Hello all, I am Dr. J. Krishnaraj, Assistant Professor from the Department of Automobile Engineering, Hindustan College of Engineering and Technology, Valley Campus, Coimbatore. In this video smart lecture, I am going to be brief about the topic called to be as an automotive ignition systems. So the overall outline of the presentation that are introduction about the part, basic components of an ignition system, types of ignition system, working principle of ignition system, components of modern ignition systems, spark timing and advancements in ignition technology, troubleshooting and maintenance, and the overall outtaken from this presentation that are conclusion. Yes, so the ignition system, as we are all aware of that, so the internal combustion engine is broadly classified into two types. So the first one is compression ignition engine, that is a diesel engine. Then second one is spark ignition engine, that is gasoline, petrol or SI engine. So on the diesel engine, so it reaches when the combustion is taken place only when it reaches the self-ignition temperature. So the auto ignition temperature of diesel fuel is lesser than that the petrol fuel. So in diesel engines there is no need for the spark plug. So there is an external agent is not need for the making and combustion. But if it is in the case of SI engine, spark ignition engine, the auto ignition temperature of the petrol fuel is higher than that the diesel fuel. Even though if it is having a higher compression, that never makes any auto self ignition, for which it needs an external member to make that combustion, for which the ignition systems are used. So what is that ignition systems? What does its function? So at the end of compression stroke, heavier compression is taken place for the air fuel mixture. By the time the spark plug will initiate and spark, that makes a combustion. For making up this function, so it needs the system called to be as an ignition system that contains some of the basic components. So what are the basic components for the ignition systems are? The first one, the primary and important component, that is an ignition coil. So on this ignition coil is nothing but it is an otherwise called to be as a high tension coil or ignition coil, like that the people are said. So on this ignition coil, it has the iron core at the middle. Okay, so you can look into this left side of the images. So these are all the types of ignition coils. So the main purpose of the ignition coil is, so our automotive electrical systems, so that contains an 12 volt of power supply. So we are giving an battery power as 12 volt. So on this 12 volt power supply is not enough to produce a spark. So how the spark is produced? So when the positive and negative terminals, either by scratching of them or else if it is very closer to that, the electrons will jump from positive to negative terminal. So by the time, so the electrons, jumping of electrons from positive to negative terminal, that visualize as a spark, and that gives as an heat energy. That heat energy is used for making the combustion. So here I am showing that the types of ignition coils. So the single coil type and coil packed type and direct coil or plug type and the external coil or plug type. So most cases the single coil style are used for this, and for an present now the coil pack type are at present now used. And the advanced technology like in turbocharged gasoline direct injection engines, the direct coil on plug types are used. So on which each spark plug will get their own ignition coil, because so that much high intensity and variation of sparks are required for that. So what is happening inside the ignition coil? So the ignition coil is nothing but inside the ignition coil it is having an iron core. It is wounded by the several primary and secondary windings. So on this primary windings it is having an thick copper wire wounded over there, and the secondary winding in connection with the primary winding it is having a thin layer, so wounded the multiples of twice in the primary windings. So what happens inside? So when the 12-volt power supply is given to that, it makes a stepping up action. So that makes a stepping up action of the power supply. Even though the power is stepping up, that is not enough to produce a spark. So for making up the spark, it needs minimum of 20,000 voltage and above. So if the required power is 20,000 voltage and above, so for making up this, additionally it needs an action called to be as with support of electronic ignition, or like contact breakers are used for producing the 20,000 voltage. So how 20,000 voltage that are produced now? So when the power supply is given to this primary and secondary windings, that makes an electromagnetic force called to be as an EMF. Okay, so whenever this EMF is collapsed with an opposing force of power supply, that creates a huge voltage of power for temporary period of time. After producing this power, so we need to distribute the power to respective spark plug for making the firing order. For example, the firing order of the 4-cylinder is 1342. So the first firing order is, first firing cylinder is 1. So we need to give the 20,000 and above voltage of power to the first cylinder. Then what is the next cylinder? Third cylinder. Then 1342. Likewise, we need to distribute the power to the respective cylinders. For making up this function, distributors are used. So the distributor can distribute the high tension of power into the respective spark plugs. Nowadays, distributorless ignition systems are introduced. Like Maruti Suzuki, they are having a technology called DDIS. What is DDIS? Distributorless direct ignition systems called to be as an DDIS, on which so the mechanical component of distributors are eliminated. Instead of that, the electronic type of distributors, which is nothing but electronics, are introduced for distributing the power supply. Types of ignition systems. So normally the ignition systems having the types called, the first one is contact breaker point ignition system. It is otherwise called to be as a mechanical type of ignition system. So on which mechanical type of ignition systems, it is having a contact breakers to make the spark at the right time, not only for the timing, and that makes the function of collapse of EMF. So yet to be the mechanical type of ignition systems are used. So you can look into this picture. So it is showing that at the middle of this part, it is having a camshaft. It is directly connected with the engine pulley. So once the engine is cranked, so the camshaft will rotate. Whenever the camshafts are rotate, that makes to actuate the function of contact breaker. These contact breakers will have the terminal, so it contacts and it retracts. So whenever it contacts, it is grounded. So one end of this contact breaker is connected with the high tension coil. It is otherwise called as ignition coil. So the stepping up power is directly given to this contact breaker. So what happens whenever these contact breakers are closed, it is that power, DC power supply is directly grounded. On the other hand, it is connected with the supercapacitors. These supercapacitors are storing the electrical energy for a temporary period of time. So on which the supercapacitors stores the energy whenever it requires, and when the contact breakers are getting open, it releases the energy. So what happens in normally when the camshafts are rotate, it opens and closes the contact breaker. So when the contact breakers are closed, the power supply is directly grounded and the required power is stored in the supercapacitor also. So when the contact breaker is open, by the time it is not possible to ground the power supply. So what happens, by the time these supercapacitors releases the electrical energy what they are stored. By the time what happens, the energies are reversed to the ignition coil. So what happens? So these reversed energy, as well as it is already ignition coil that contains a stepping up of power supply. So it is in the EMF in state. So both are collapse with each other. That EMF is collapsed. So what happens by the time? So high tension of power is produced. These high tension powers, so normally that exists above 20,000 of voltage. So that power supply is directly given to the distributor and distributor will distribute the power supply to the spark plug. So the spark plug will produce a spark. Similar in the way electronic ignition systems are used. So in the mechanical type of ignition systems that contains some of demerits. So on the demerit is, so it is keep on contact and retard. By the time the contact breakers starts to erode. So when contact and retard, it produces little bit spark over there and it starts to erode. So the function is later it will produce a misfire and other things. So this is the main drawback. And so the retard timing of sparks also possible in the mechanical type of ignition systems. But if it is in the case of electronic ignition system, they are simply eliminating the contact breaker. Instead of that, they are placing the position sensor. So Hall effect sensor, technically said it is a Hall effect sensor. So the Hall effect sensors, so on the right hand side the schematic layout is shown over there. So the Hall effect sensor, it is keep on monitoring the position of crankshaft. So what is the exact position of crankshaft? Based on the position, it will give the signal to the ECU. So there is a microcontroller is given for the ignition system. That microcontroller keep on receiving the signal from the position sensor. Based on that does the remaining functions, that is collapsing of EMF and others. So this exists, the same supercapacitor also will be there, only they are eliminating the contact breakers. So instead of contact breakers, it is provided with the position sensors. So once the position is reached, that tooth flywheels gives the signal. So that makes the collapsible things, and remaining things everything are same. So on which the electronic ignition system, the accurate function of spark is we can able to achieve. So the contact breakers are wear out due to the continuous function because it is a mechanical component. So that has to be eliminated in the electronic ignition system. So the life part, so the life cycle of the electronic ignition system is too long when compared to the mechanical type of things. And the mechanical type of contact breakers, we need to change the contact breaker frequently, but that has to be eliminated in the electronic ignition system. On the other components of modern ignition system is spark plugs. So on the spark plug, so what is spark plug? So it is a mechanical component. So on this mechanical component, the spark plug will have a positive and negative terminals. Positive and negative terminal. When the power supply is given to this positive and negative terminals, it in between the positive and the negative terminals, there will be a maintaining of minimum of air gap. So with a minimum of air gap, 0.6 mm is universally they are maintaining for the air gap. So the central electrode, so the central electrode is called to be as a positive terminal. So it is directly connected to the distributor. So the high tension above 20,000 voltage is given to this central electrode called to be as a positive electrode. And the negative electrode is directly connected with the threaded part of this spark plug. It is directly threaded over the engine cylinder head. So it is which means that it is grounded. So normally the electrons will jump from positive to negative terminals. So here we are using high tension of power, that is in 20,000 voltage and above. So what happens, with a minimum of air gap, the electrons will jump from positive to negative terminals. That we are visualized as a spark. So that spark will normally have a temperature. So that temperatures that are used to make a combustion. So it is the main function of this combustion process. Then the modern ignition systems like an Audi, BMW, like these kind of vehicles, what they have called to be an ignition controlled module, ICM, ignition control module. So these modules will provide an individual of modifying the spark timings. So these ignition control modules can able to vary the spark timings. So even though if it is a mechanical type or electronic type, the spark timing cannot be varied. So what is the preset value of the spark timing? The same spark timing is given for all the working cycles. If the engine speed is keep on increasing, based on the spark timing also will increases. But if it is in the case of sudden acceleration, deceleration, full load enrichment, or high air fuel ratios are given, by the time we need to change or make an advancements of ignition or need to vary the spark intensity level based on the air fuel mixture. So based on the air fuel mixture, whether if it is a stoichiometric or lean mixture or rich mixture, full load enrichment, that is called to be seen. Based on that, we need to vary the spark intensity level. For making up this functions, it is provided with the ICM, ignition control module. These ignition control module, I am just showing that Audi ignition control module in this image. So these ignition control modules will vary the function of spark advancement or retard sparkment or increase the intensity of the spark level. So these functions are carried out in this. So what is spark timing and advance? So if you are suddenly accelerating or decelerating, or if you are giving if you are demanding high power or high torque, by the time the driver is demanding the power or torque or sudden acceleration to that vehicle. So for making up this function, we need to reduce the lagging of time. That lagging of time, if you want to reduce means, so it is essential to make all the functions are in advance. So for making these advancements of functions, so the regular operations it has to be made as an advance. So the spark has to be made as advance. So normally the spark is given 15 degree crank angle before TDC. But if it is an advancements of spark, so that might be in 20 degree or 30 degree crank angle. So what happens? All the operations are making advance. Similar in the way retardment. So while declimbing of the hill station like that. And if suddenly accelerating or if you are demanding full load enrichment, by the time heavy rich mixtures are entered into this cylinder. So the normal spark intensity level is not enough to burn or make a combustion. By the time the spark intensity level need to be increased, for which it needs a high voltage of power. So all those things can be carried out by ICM. The next is advancements in ignition technology. So what are the advancements in the ignition technologies? Coil on the plug. So on the third slide, I am just showing the types of ignition coil. On this types of ignition coil on the plug, COP systems, enhance the durability and the performance by placing an individual coil on each spark plug. Instead of giving a single ignition coil for all the spark plug, whether if it is, suppose you can imagine that if it is having a 6-cylinder engine, it is very difficult to give the required power for all the cylinders at the high speed. So by the time there will be a lagging of spark intensity, that is a voltage. So for making up this, individual spark plug will get their own ignition coil. So we can vary the individual cylinder spark intensity and advancements and retardation functions separately, not by a common. So in each cylinder will work by their own performance level. The next is variable valve timing, VVT or VTVT, variable time valve timing. These technologies optimize the engine performance and efficacy through dynamic time adjustments. So based on the dynamic requirements, sudden acceleration, deceleration, full load enrichments, or demanding more power. So dynamically that can varies the engine performance. The next is ion sensing ignition systems. So the real-time detection of engine knocking and misfires for improving the safety and performance. So the misfires or diesel knocks are occur. In petrol engines, misfires or detonation occurs. So this ion sensing ignition systems can recognize the misfires. Based on that can alter the spark intensity level, which means that sparking level on this system. So these are all some of the advanced ignition technologies. So what are the troubleshoots we need to find out and maintenance? So the common issues that are identifying and address common problems such as ignition coil failures, spark plug issues, and control modules malfunctions. So due to this, these are all some of common issues. So we need to replace the ignition coil, spark plugs. For every 10,000 kilometers, we need to change the spark plug. It is easily get wear out. And the control modules. So if you keep on running with an different driving conditions, there might be a possibility of malfunctions. So the diagnostic property, utilizing the diagnostic tool to address and access the health of the ignition system, including the use of OBD scanners and multimeters. With the help of multimeters, we can able to identify the basic electrical problems. With the use of OBD, onboard diagnostic tool, it is an advanced technology that capable of identifying the what is the fault exists in the system and where the system has gained the problems, and what is the health status of individual components. All those things we can able to identify by means of OBD tools. So the normal maintenance practice are establishing a regular maintenance schedule for the components like spark plug and addressing the issues proactively to prevent the performance issues. So what is the overall takeaway apart from this presentation? So the summary of the key points discussed through the presentation of an automotive ignition system that highlights an critical role of ignition system in automotive performance and efficiency, emphasizing the importance of understanding the maintain the ignition system of optimal vehicle operations.